optimized Genesis sequence.
Hello, I'm Trisha. Welcome. I'm here to talk about developer productivity engineering. I work for Gradle. I'm a lead developer advocate, and God, I can't even read my own notes, and I've seen this slide 1,000 times. Oh, I'm a Java champion and stuff. That's what I do. And in between working at JetBrains, where many of you may have seen me before when I was at Devox, and working for Gradle, I kind of contributed to a couple of books. And the reason I mention the books, apart from buy my book, please, is that the theme of these books, even though they're sort of Java and IDE stuff, is really around productivity and being productive as a developer, which, if you saw my talk yesterday, you'll understand that I kind of care about, mostly because I want us to have better lives as developers, not because I want to squeeze more code out of us. So this is kind of how I used to feel when I first started programming. You're like, oh my God, I got the computer to do something, which we occasionally still get that feeling when it does what we want it to, and which is not that often. But imagine these kids have been writing, not a nice Hello World application, but something which has to start like Docker containers and has to run builds which take 20 minutes and has to wait 40 minutes for the feedback on their tests. They might feel a little bit differently about programming and how it makes you feel. And the reality of most of our day jobs as developers is that we don't even get a lot of that time for coding. And if we do start time, this is like an ideal day. Notice there's no meetings or, other stuff that we have to do. This is like a good code day. And in a good code day, we write some code, but we also do waiting for builds, or we are, trying to debug a particularly difficult problem. And when you find the answer, you realize it wasn't a difficult problem. It's just hard to debug. And, and then maybe we go to lunch, and then maybe after lunch we get stuff working, and then we push stuff to CI, and then we wait for CI to finish doing what it's doing. And of course, we could multitask, and we could be working on multiple things at once while we're waiting for this other stuff. But that's just as bad, because context switching absolutely kills us. Now, as I mentioned, this is an ideal coding day, and if you saw the talk yesterday, you already saw this. This is a 2019 survey which said that we spend only 32% of our time writing code. I'm not sure I really agree with this because it put testing in a different box, and I think testing and coding is the same thing. But anyway, so we only spend 32% of our time writing code. So in those days where we have good code days, the last thing we want to be doing is spending time waiting for other stuff to happen, or context switching, or like thrashing in our brains. There's a quote from Dell which says, "Bottlenecks in the toolchain are holding back the rockstar 10x developers." I can't help but say that with irony, because I do feel a bit like a 10x developer is somewhat mythical, like unicorns in El Chupacabra. But there is such a thing as there is measured improvements in certain types of developers perform better. So let's drill into this a little bit. Let's find out where the myth of the 10x engineer comes from. There's a book from, 1980, 1970 something, called Peopleware. And this book was all about looking at productivity in engineers. And what they did is they set up this thing called the coding wars. And in the coding wars, you would have two engineers, two developers, working on the same problem, and they would measure how effective each of these developers was at solving the particular problem. And what they found is that the best programmers outperformed the worst by roughly 10 to 1. So maybe this is where the 10x engineer idea comes from. But if we drill in a bit deeper, we can find out what really mattered in this. And what mattered was the programmers who were competing against each other performed at roughly the same level. And that's kind of weird, right? Because they're not collaborating on a problem. They're trying to compete with each other on the problem. But what is important is, which I just said, what is important is that they came from the same organization. And they were working in their environment from their organization, their normal desk, their normal computer, their normal everyday job. So the environments were the thing which impacted these developers' productivities. So it wasn't that the best programmer outperformed the worst by 10x. It was the best organization outperformed the worst by 10x. So it's not about individual programmers. And we've had this 10x idea for a long time, and it's really nothing to do with an engineer's innate ability. It's about the environment that that engineer works in. So, for example, the better performing ones had more space to work in. They were able to silence their phones. In the days we used to have phones on our desks. They were able to have more privacy, more quiet. They were able to focus more. It was the environment, it was the organization that made them productive, not necessarily their individual innate abilities. So the summary from the book was, the bald fact is that many companies provide developers with a workspace that is so crowded, noisy, and interruptive as to fill their days with frustration. That alone could explain reduced efficiency, as well as a tendency for good people to migrate elsewhere. So now you've got two problems. One, your environment is not conducive to an engineer performing particularly well, and two, your good engineers are going to leave those environments. Or if they see it before they join, they're not going to join your organization. So if you don't provide a good environment for engineers to survive in, not only will they not perform well, but you'll lose anyone who has any choice in where they're going to work. So this brings us to what I wanted to talk about today, which is something that Gradle calls DPE, Developer Productivity Engineering. So DPE is a software development practice used by leading software development organizations to maximize developer productivity and happiness. I really want to put the happiness in bold, because that's the thing I really care about. So we've been talking about DPE for, I don't know, 2-3 years, something like that. It kind of lives in a similar space to platform engineering, developer experience. A lot of those things have a lot of overlapping ideas. But DPE is very specifically focused on an engineering approach to developer productivity. So the kinds of problems it solves are things like, I wonder if my spotlight actually works. No, it doesn't. And I can't wave at this thing because this screen is so big that I have to jump really high to wave at anything. But the idea is that, and the camera hates me because it's trying to follow me. So the problems that DPE solves are things like builds that break too easily, tests that fail too frequently, processes that take a long time, like long builds or long test suites, and things that should not have failed, things that should have been caught earlier. Now, when you add up all of those small things that impact every individual developer, and you times it by the number of days a year that developer works, and you times it by the number of developers in your organization, you end up with a huge impact to your organization's productivity and a huge increase in the cost. So DPE is about looking at the lower level, at the individual developer level. What can we do to help individual developers to be more effective? How can we shave off minutes or seconds from the build time to help make things a little bit more comfortable for our developers and have a big impact at the end of the day? And so we're kind of saying that DPE sits after all of these things that we've been doing, like chip manufacturing and business process re-engineering, which I think is something that Ford was doing when I joined them at the end of the 90s. Agile, Lean Six Sigma, DevOps, and then DPE is like the next thing, because the idea is that those things that we've been doing, moving towards Agile, moving towards iteration, things like 12-factor, that hasn't found everything. It's made our processes more efficient, more effective, but there's still plenty of other things that we can fix, like problems with the developer experience itself. So this comes back to our 10x organization. And our 10x organization should be reducing build and test feedback times, helping developers troubleshoot problems, and improving the consistency and reliability of builds. I think we look quite a lot at things like long build times, and we think, oh, that's kind of awkward. But reliability is more of a problem. Because if you are 15 minutes into running a build, and then it fails randomly, and then you rerun it and it passes, you've just lost half an hour to the reliability problem. Obviously, you don't really want a build that takes 15 minutes either. That sounds very painful. So let's talk about pain points. The first pain point I want to talk about is waiting for builds and tests to complete. I mean, I do work for Gradle, so this is something that we see a lot in the customers that we talk to. They come to us because they want to improve their build and test cycle. But it's not unusual to have a problem with long build times. Is anyone here, or the teams that people work for, are you tracking how long it takes to run local build and tests? I would say that's about 5% of people, 10% of people. That's good, actually. When I was asking people last year about this, almost no one was tracking local builds and tests. So if you ask someone how long does the build take for your local developers on your local laptop, they'll say, well, probably 5 minutes or 2 minutes, or it's very much finger in the air, because we're not really measuring it. Almost no one is measuring it, actually. I'll come back to this. So there's another book. My old boss used to call this the ancient business wisdom of the 70s and 80s, which makes me feel very old. And the book called The Goal, which kind of made the theory of constraints popular. In this book, they say, the only initiatives that will positively impact performance are ones that increase throughput while simultaneously decrease cost. Now, the reason why I think this is important is lots of organizations are looking to cut cost. but just straight up cut cost. And that's not going to increase your throughput. That's not going to positively impact your performance. That's probably going to negatively impact your performance. So you're looking for things which can do both of these things, increase throughput and decrease cost. So we're going to look at that in relation to build times. These are two genuine teams that we worked with. In the first team, there were 11 developers. The build time was about 4 minutes, which in my world, when I used to work at enterprise, is a really good build time. And the number of local builds they can run a week is 850. And in the second team, they've got half as many people. They've got 6 people. Their build time is 1 minute, which means that even though they only have 6 people, they can do 1,010 builds a week. So that team with half as many people can be more productive. That's like, what, 20% more productive in terms of throughput, because they can run more builds. And the reason they can run more builds is because their build time is significantly smaller. So even if you have, by many organizations, a short build time of 4 minutes, you can still have huge improvements on your productivity by getting that down to 1 minute. And I want to talk a bit about why fast feedback is important. And again, I have trouble with this because I can't do it with this screen. I usually point at all these different things. How can I do this? I guess I could stand underneath it here and wave gently. Plus also I get to say hi to this side of the room. Hello. So if we have faster feedback cycles, by which I mean shorter build times, a smaller amount of time before we get the results of our tests, we can build more often, which leads to smaller change sets, which leads to more efficient troubleshooting. If it's smaller, it's easier to find some problems, and fewer merge conflicts, which is every time faster, mean time to release. I don't know, you get it out there faster, which leads to increased productivity and increased quality. I have to go back over here. Should have worn my trainers. And then if you're building more often, you can also do earlier quality checks, and so you have fewer expensive downstream instruments, which means that you find problems sooner. You find them on your local laptops or maybe on CI, and then so your quality is improved. And of course, what's better for us as developers is we have less waiting around for our builds, which means less context switching, which gives us more focus, which leads to that wonderful state of flow. Context switching kills us productively wise. So if you've got more focus, you've got better quality and better increased productivity. So overall, having shorter feedback cycle times, being able to run your builds faster, being able to get the feedback from your tests more quickly, has basically no downsides. It improves productivity and quality. So it's something we should definitely be aiming for. And how do we do this? We can do this with acceleration technologies. I'll go through all of these. So when you run all of these acceleration technologies together, you get a much better feedback cycle time. So the first acceleration technology I want to talk about is build caching, which I think we talked about yesterday as well. Build caching, I mean, a build cache is like any other cache. If you have the same input, you should be able to get the same output. So if you're building the same code with all the same inputs and the same files or whatever, the output of that, the classes, the artifacts, all the rest of it, even the test results, are all the same. So if you run a task once or a goal once, you can cache those results. And then next time you try and run it, you don't need to run it at all. You just get the results from the build cache. And this works for in Gradle's product Develocity, which I haven't mentioned yet. We have a product called Develocity. In Gradle's product Develocity, we have build caching for Gradle, obviously, Maven, and SBT. Now, normally, I run a live demo at this point with Maven to show you how it works. And normally what happens is I run the build, it takes 5 minutes. I don't run a 5-minute build in front of you, because that would just be mean. But I run the build, it takes 5 minutes, and then I add the caching, and it takes less than a minute. However, the demo gods are not kind to me today. And they did not want to grant their demo goodness to my laptop, so my demo did not work. So you have to look at a chart instead. But this is a genuine example of when Spring Boot started using the build caching from Develocity. Their build time was originally 20 minutes, and then when we just added the build cache without tuning it, then it became like 3 minutes, and then you can optimize it further if you want to. And the reason I mention this example is because it's very similar to the other examples I've seen. It's not an extreme example. With a build cache, you usually get down to sort of 20% of the amount of time to run the build. It works best with multi-module projects because you cache the individual modules. And it works really well for Maven projects because Gradle already has incremental builds, which helps anyway. Now that's helpful on your local machine, but remote build caches, I think, are where it's really interesting, because which environment is constantly building and testing your code? Well, CI is, right? So if CI is constantly running and building and testing your code, you can put those results into a build cache. And then when you come to check out that code, you don't have to run that build again. CI already ran that build. So you can get the results from the build cache. So you imagine that effect multiplied over all the developers in your team, and you can really start saving a whole bunch of time by using a remote build cache. Another acceleration technology is test distribution. Generally, so we already run our tests in parallel in a lot of different places, but where are we? This is local, right? So on your local machine, you can run your builds in parallel. You can fork them. In CI, I really hope that you're running a whole bunch of agents and doing stuff in fan-out. However, there's some disadvantages to both of those approaches. With the local build, going parallel is limited by the number of CPU cores you have, obviously, because you can't run more things than the things you have to run them on. And when you run stuff in CI, CI fan-out often requires some sort of manual configuration. Not always, but it can require manual configuration. And you only really get this huge parallelization in CI and not on your local machines. So test distribution is a way of being able to go really parallel with when you run your tests, whether you're on your local machine or whether you're in CI. And you can even use the same agents for all of those things. And so you just have a bunch of agents running on a bunch of different machines. So we did this when I worked at LMAX. We wrote our own test distribution thing. So our CI environment would run test distribution over a whole bunch of agents. And the agents were they were like VM. This is a while ago. So VMs on our on-prem hosting stuff, but also any of our spare development machines, which happen to not really be doing anything, would have agents running on them too. So you can just use any CPUs which are kind of lying around. And so you get to run your tests much, much faster. And you generally find that if you double the number of agents you're running, you halve the amount of time it takes. At some point, there's not a lot of point in adding more agents because you've kind of reached the optimum amount. But you can go really hugely parallel. And Netflix tried this, and they got their testing cycle time from 62 minutes down to under 5 minutes, which I think we can really, if we were thinking we have to wait 62 minutes for all of our integration tests and acceptance tests, we're obviously going to multitask during that time and go somewhere else. But if our tests can finish in 5 minutes, we can just wait for that to finish, go and get a coffee, and come back and go, oh, I broke something. That's definitely a good improvement in their feedback cycle time. Of course, we're in 2024, so everyone's talking about machine learning. It would be pointless to have a talk without machine learning. Meta have a white paper on what they did to try and speed up their tests. What they wanted to do is not run all their tests, which makes loads of sense, right? And they were working on a huge monolith. And so with a huge monolith, they have loads of tests. And every time you make one change, they had to run all the tests. And they were like, this seems dumb. I don't think we should be doing this. How can we figure out which tests we need to run with these lines of code? And originally, they were looking at dependencies. So if these lines of code have changed, which tests have some sort of direct or indirect dependency on those lines of code? And what they found is, generally speaking, every test is dependent upon every line of code, which is not very helpful. So you always end up running all the tests. And when they use machine learning to figure out which tests provide the most useful information when you change these lines of code, i.e., which tests are most likely to break if something's wrong with this code, then they found that generally you only need about 30% of your tests, not all of them. So what we did is we took this and we put this, is the video going to work? Yeah. We took this, the ideas that Meta had put into the white paper, and we use a machine learning algorithm in Develocity to decide which of your tests need to run given your changes. So it learns off the CI environment, and it will figure out, you don't have to turn it on straight away, you just have it learning. And it sits in the CI environment and takes a look at when you make these kinds of changes, which tests are the most useful tests, which tests are most likely to fail. And so then it'll tell you over time, if you turn it on, it tells you, you only need to run these tests. And it's tunable as well. So you can say, I want more accuracy, so it'll run more tests, or I want more speed, so it'll run fewer tests. And you don't necessarily want this on all of your environments. You probably don't want it on your release branch. You probably want to run all your tests. But for your local build, really what you want is to run the indicative amount of tests, which will show you if you broke something or did something stupid. So then if you do all of those things together, use a build cache so you don't need to build as many things. You use predictive test selection to select only a subset of your tests. You use test distribution to distribute those over a bunch of different agents. And performance continuity I'll come to in a minute. You do all of those things, and that will really bring down your build and test feedback cycle time. I think I've been asked this question a bunch, or my teams have been asked this question a bunch. Is the build and test cycle fast enough? And often we'll answer that with, well, yeah, it's fine. But I think what we've seen with the fact that there are acceleration technologies is that this isn't really the right question. And we could be asking ourselves, is the build and test cycle as fast as it can possibly be? Now, it will never be as fast as it can possibly be, never, that's impossible. But that's what we should be aiming for. We should be constantly looking at how can we improve the build and test feedback cycle time. And I think a lot of us tend to be like, well, tests just take a long time, or the build just got longer over time. And I think we need to have a different mindset on this. We need to be bringing that feedback cycle time down so that we can stay in the flow more easily and we can be more effective as developers. The next pain point I want to look at is inefficient troubleshooting of broken builds. I've worked in a bunch of organizations where there's really only one person who knows the build or how it works. Whether it's like some shared expert amongst a bunch of teams in a bigger organization, or whether you're in a small team and it's that one guy on the end who understands Gradle, there's always just a small amount of people who kind of really understand how the build works, and particularly when it works in CI environments or locally. And so when your build breaks locally, you're not always in the right position to be able to figure out what on earth happened. You quite often go, well, I've never seen this error before, I don't know what to do. And you ask that person, can you help me with that? But that's quite difficult, because especially if you're remote, because that person can't see your screen, and that person didn't run your build. And that person runs their build, and it works. And they're like, well, it works on my machine. What you want to do is you need to be able to share the information about your build, even if it's a local build, with someone else who can help you with that build, more often than not. So you can use something like a build scan. Gradle has free build scans, so you can use a build scan to share that information. And the build scan will show you, obviously, kind of how the build looked when it ran. So you can see the log and any exceptions. But it'll also show you the infrastructure it ran on, which version of Java it was using, which switches of the build it was using. Are there any deprecated things in the build? And what's quite helpful is it can show you the dependencies that you used. So when you say in your Gradle build file, oh, I want these dependencies, they're not always the dependencies which are actually used when you run the build. But the build scan will show you, oh, well, you asked for these dependencies, but you actually got these ones. And that can sometimes help you see exactly what the problems are. But the nice thing about the build scan is you can share this with someone else. So it's a web page, so you say, look, this was my build that failed. You can even link to very specific stuff. And you're like, look, I got this error, or I'm using this dependency, and that's kind of weird. Can you help me with it? So you're able to troubleshoot problems much more quickly, especially if you need to collaborate with someone on that. And then if you gather information from lots of things like build scans, you can get some really interesting information. Like, you know what? This error seems to affect 20% of our developers. Maybe if we fix this problem, we can be way more efficient. We can save X amount of time, or we can save pain to 20% of our developers. So you can gather that information to look for trends and patterns and see where you'd be most effective spending your time fixing problems. The next pain point is something I really enjoy ranting about, which is why I got this t-shirt made. Flaky tests. Flaky builds and tests are extremely irritating. They're very annoying because they're not reproducible, so you run it again and it just kind of works. And they're just very irritating because the first mindset you have when anything fails, even if it's not a known flaky thing, is you just rerun it. And then you rerun it until maybe it goes green, and then you just go, oh, it's fine, it works. And then you just check it in or push it to production. And you don't really ask yourself, was it the failure or the passing that was the correct behavior? Because any sort of failure is perhaps an indication that something's not quite right. So I'm not a big fan of flakiness because it really interrupts our flow. It means that we have to rerun things. It slows us down, and it erodes our trust in our test suite. This was a survey into the developer experience of flaky tests, fairly recent actually. And it said, our analysis revealed that rerunning the failing build and attempting to repair the flaky test were the most common actions. Okay, don't think that's a huge surprise. I think what's most interesting is it said, our findings also suggested that developers who experience flaky tests more often are more likely to take no action in response to them. So here's the main problem with flakiness. As soon as you have any flakiness in your builds or tests, you start ignoring failures. You start ignoring flakiness, but you start ignoring real failures because you're like, well, sometimes it just fails. And then you've invested this time and energy in writing tests and running your builds, but you're not doing anything with the output because you're like, well, it's just a bit rubbish sometimes, isn't it? So it erodes our faith in the build and test. So what you want to be doing is you want to be finding your flaky tests. Devvelocity has a way of finding flaky tests, obviously, otherwise I wouldn't put it in the talk. But when I worked with Dave Farley back in London a few years ago, I was the flaky test detector. So I would go in the mornings and I would rerun all the failing tests locally to find out which ones are really failing and which ones are really flaky. I do not recommend this, but what they did is some very kind person who's better than me actually just automated that process and put it all on a report. So every morning you get a report saying, these tests are failing and these ones are flaky. So the first step in dealing with flaky tests is to identify which of your tests are actually flaky. I have loads more information on flaky tests because it's like my favorite topic. It is actually the reason I joined Gradle, so I could talk about this stuff. If you're interested in finding out the causes of flaky tests and test intermittency, Dave Farley calls it, he's got this video on the 5 causes of test intermittency. There's a link at the end of this presentation to a page on my website which will have all of the links on. So this is a great video. And I also wrote a few blog posts for Gradle about why you want to fix flaky tests, how to find them, how to fix them, and then a case study on how some banks are addressing flaky tests. I will pause for a minute while people take photos. This is available at the end of the presentation as well. So another pain point we have is that we don't have a lot of observability on some of the problems facing developers. We have observability in production, I really hope. We have a certain amount of observability and reports and metrics and stuff on our CI environments or maybe staging environments or whatever. We don't really know what's going on in our developers' environments. So when we talk about developer experience, when we talk about developer productivity, we don't really have any good idea of what's negatively impacting the developers. And without the ability to actually see what's going on, we're going to have problems maintaining any good work we've done in things like the acceleration stuff we've been doing or troubleshooting tests. So without seeing the build times, the test times, the errors that we have, the problems can keep sneaking back in. This is just entropy. The reason why my live demo doesn't work is because I haven't looked at that code for about 3 months. And over time, and I'm not talking about, yes, the code has changed over that time, but I'm not getting a more recent version of the code. I'm getting the same version I demoed last time. But it doesn't work now, and I'm not quite sure why, because I'm just going to blame entropy. Over time, stuff just gets bad. Because builds in particular are not necessarily reproducible, because even though you've got the same code and you're on the same laptop, it might be downloading dynamic dependencies, or it might be doing something, something you don't control. So I don't know what's wrong with my demo, otherwise I would have fixed it. But you need to be constantly looking at problems and constantly moving towards fixing those problems, or over time, things just get worse because entropy. And this is a quote from Mike Nygaard's second edition of Release It. And I really love this because I haven't really thought about it this way. It says, the tools, services, and environments that developers need to do their jobs should be treated with production-level SLAs. The development platform is the production environment for the job of creating software. So we often talk about the development, the production environment, and maybe some of our CI environments, but we don't think about our own laptops and our own test environments as being part of a production-like environment. This is dev, And dev is always a bit like, well, that server's down, or my laptop's slow today, or, they won't give me a new laptop because I'm just a developer. But the code that ends up in production, the code that our customers and our users end up using, starts on your laptop. Your laptop is a very critical part of the path to production. And so I think we really need to be looking at what's happening all the way along from when you write the code to production to figure out where are the bottlenecks, where is the toil, what is slowing us down. And of course, it's important from a security point of view as well, but as soon as you start talking to developers about security, they start to snooze, so I'm not going to mention that. And then this pain point is about the inefficient use of CI resources. I kind of assumed when I first started looking at this topic that if you are going to use acceleration technologies, if you're going to speed up your builds and tests, if you're going to spend less time building stuff and testing things, then your CI costs will come down, particularly if you're in the cloud, right? Because you're going to be using it less. It turns out that that's not necessarily the case, because what happens is you might just run more builds. So now it doesn't take as long. I can actually just push more frequently and do more smaller changes. So it's more about an efficient use of CI resources. So it can bring down CI queue times, for example, and it can make you can get more effective use out of the CI environment that you have. So, either way you win, but I don't want to say you're going to spend less money on CI if you do this, because you might not. But you might be able to get more builds through CI. Oh, I've got loads of time left, and I'm already summarizing. That's what happens when your demo goes away. So we might have time for questions, which never happens. In summary, 10x developers might be a myth, but 10x organizations are real, and they can be created and nurtured. Developer productivity is deeply linked to developer experience. We're more productive, and this is what we talked about in the presentation with Holly yesterday. We're more productive when we have fun. We're more productive when our environment is better. We're more productive when we are not hanging around waiting for stuff to happen. If you don't do anything about productivity, life will get worse. It won't just stay in a steady state. It will just continue to get worse over time if you don't actively do something about productivity. Fast feedback, efficient troubleshooting, and reliable cycles are key to getting the developer productivity that we need, particularly in terms of freeing us up to be in the flow and not jolted out of the flow by the toil and the trouble. Now, I've given a whole bunch of technologies and ideas here, so the one takeaway really is start with observation and take action on the data. So you don't have to do all of these things, and you don't have to call Develocity sales guys, although they'll be very happy to hear from you. But what you do need to do is you do need to have a look at what's really impacting a developer's experience in the day job. So you need to be looking at, obviously our suggestion is things like build times and test times, but it might be things like how much time are they spending in meetings, and how much time are they, context switching. And this is where the SPACE framework is quite good for measuring developer productivity, because it's not just about activity, it's also using questionnaires to ask developers what slows you down, what's getting in the way, and you can take a sort of sense of what the problems are, and not just guess and make wild changes depending on what you think is wrong. And then proactively solve problems for the whole team. The thing I really like about DPE is that you can find a problem which might be impacting an individual developer, but then you apply it across a team level. I think this is what appeals to me about platform engineering. Instead of just fixing individual problems one by one, like one person has a problem with the build time, because for them it's frustratingly long. But you can get a 7-minute build and shave it down to, 5 minutes. But then you apply that across the whole team or the whole organization, you get this multiplier effect to the productivity. And I really like that. I really think about the individual, but being able to apply it to a wider number of people. And then talking about joy yesterday, one of the results of implementing DPE-like practices is that it fosters developer joy. So 84% of people we surveyed said that DPE really does lead to developers being happier. And because you're going to need to sell this to the business, because you can't just say, oh, we want to be happier. Let's talk about how it impacts the whole organization. So if you if you improve your slow builds and your slow feedback cycles, you get faster delivery, which is increased revenue. You also get improved productivity, so you get resource efficiency, which decreases cost. And if you address the inefficient troubleshooting, testing, and CI, you get increased productivity, decreased cost, but you also get increased quality and a better brand image for your organization. So I'll leave you with some next steps. We have the obligatory QR codes. The black QR code will take you to the page on my website, which has links to the things that I was talking about. And the blue-ish QR code will allow you to win a copy of my book. So please do click on those. Thank you very much. There is actually time for questions, and I'm kind of weirded out by this because I never have time for questions. Does anyone have a question? Wow, you can get 15 minutes back from your lives. Thank you.
All systems are nominal. Initialize Genesis.